Run a powerful large language model locally in just 90 minutes with these 13 steps. This guide will take you through everything you need to know to get started. First, let's focus on choosing the right hardware. It's crucial to have a machine with at least 16 gigabytes of RAM and a GPU with 8 gigabytes of video RAM. Consider a GPU like the NVIDIA RTX 3060, which provides a solid balance between performance and cost. This kind of hardware will support the demands of running a large model efficiently. While consumer hardware like this is a great investment, cloud services offer an alternative. They provide scalable resources but often at a higher recurring cost. Let's compare the cost and performance of using consumer hardware versus cloud services. Consumer hardware requires an upfront investment, but cloud services can add up over time. For many, the upfront cost of hardware is justified by the performance gains and long-term savings. However, it's essential to evaluate your specific needs and budget. Ultimately, the right choice depends on your priorities. If you value consistent performance and long-term savings, consumer hardware is the way to go. Welcome to the next step in setting up your environment. First, we'll install Python version 3.8 or later. This is crucial for ensuring compatibility with most modern libraries and frameworks. Once Python is installed, it's essential to create a virtual environment. This isolates your project dependencies, preventing conflicts between different projects. You can use either venv or conda to create your virtual environment. Both have their pros and cons, but either will work for this setup. After setting up your environment, ensure pip is updated to the latest version. This package manager is vital for installing and managing libraries efficiently. Next, we'll install essential libraries like NumPy and Pandas. These are often prerequisites for machine learning frameworks and provide powerful data manipulation capabilities. By setting up a proper environment, you ensure a smooth workflow and avoid common pitfalls related to package management and compatibility issues. Downloading a pre-trained language model like GPT-3 is an essential step in setting up your environment. We'll guide you through accessing platforms such as Hugging Face's Model Hub to download these models efficiently. To download a large model, you'll need sufficient storage space. These models typically require between 20 and 40 gigabytes of disk space. Make sure your system has enough available storage before starting the download. A stable internet connection is crucial for a seamless download experience. High bandwidth ensures that the model downloads quickly without interruptions. Platforms like Hugging Face provide a user-friendly interface to search and download models. Navigate to the model page and simply click on the download button to get started. It's important to understand how these models are structured. Typically, they include configuration files, vocabulary files, and the model weights themselves. Once downloaded, you can verify the integrity of the files to ensure everything is in place. This helps prevent issues when running the model. Remember, having adequate storage and bandwidth are key to a smooth download process. Ensure your setup meets these requirements before proceeding. With the model downloaded and verified, you're now ready to move on to the next steps of setting up your environment. Before you can start using machine learning frameworks like PyTorch or TensorFlow, you need to install them. It's crucial to specify the exact version numbers to avoid compatibility issues later. Let's begin with installing PyTorch. Visit the official PyTorch website and select your operating system. Use the command they provide to install the exact version needed for your project. Once PyTorch is installed, it's important to verify the installation. You can do this by running a simple script to check if PyTorch is correctly set up and ready to use. Next, let's move on to installing TensorFlow. Similar to PyTorch, head to TensorFlow's official site, select the appropriate version, and follow the installation instructions provided. After installing TensorFlow, verify its installation by running a test script. This will ensure everything is configured correctly and there are no hidden issues. It's also a good practice to create a virtual environment for these installations. This keeps your dependencies organized and prevents conflicts between projects. Finally, regularly check for updates to these frameworks. Staying up to date ensures you benefit from the latest features and security patches. Configuring the model for local execution begins with adjusting configuration files to align with your hardware's capabilities. This ensures that the model can run efficiently on your system without overloading any component. Start by modifying the configuration files to match your hardware's specifics. such as the number of CPU cores or available RAM. This step is crucial for optimizing performance and avoiding unnecessary resource strain. Setting environment variables is another key step. These variables help the model locate necessary files and libraries, streamlining the execution process. A common mistake is setting incorrect model paths, which leads to execution errors. Always double-check your paths to ensure they're pointing to the right directories. If you encounter path issues, consider using absolute paths instead of relative ones. This can often resolve directory-related errors by providing a direct route to the files. Remember, ensuring compatibility between your configuration files and hardware is crucial. This prevents bottlenecks and maximizes efficiency during model execution. In summary, configuring your model correctly involves careful attention to detail and a solid understanding of your system's capabilities. With the right setup, you'll be ready to run your model smoothly. Running the model locally is a crucial step for testing and development. First, navigate to the directory where your model files are stored. This is your starting point for executing the model. Next, open your terminal and execute the command to run the model. Typically, you'll use a command like python model py or /run model.sh. Ensure that your environment variables are correctly set to avoid execution errors. Once the model is running, you'll see logs indicating the progress. These logs will help you track the model's execution and pinpoint any issues that arise. To ensure the model runs efficiently, monitor your system resources. Use tools like NVIDIA SMI to check GPU usage and ensure your system isn't overburdened. If you notice high resource usage, consider optimizing your model or upgrading your hardware. This step is key to maintaining performance and efficiency. Finally, once the model execution is complete, review the output files generated to ensure they meet your expectations. This final check confirms that the model has run successfully. Running a model locally allows you to have full control and flexibility over the process. This setup is ideal for both development and testing, providing a real-world environment for your model. In this chapter, we'll tackle some of the most common issues you might encounter when running models, such as out-of-memory errors and CUDA errors. We'll also provide practical solutions to these problems, ensuring you can get back on track quickly. One frequent issue is an out-of-memory error, often seen when the batch size is too large for your GPU's capacity. Reducing the batch size can help mitigate this problem and prevent system crashes. CUDA errors can be frustrating, but they often stem from outdated GPU drivers. Keeping your drivers up to date can resolve many of these issues, allowing your system to run models more smoothly. Here's a real example of a CUDA error message. Runtime error, CUDA error, out of memory. This usually indicates that your GPU cannot handle the current workload. To resolve this error, you can try reducing the model complexity or freeing up GPU resources by closing unnecessary applications. These steps can help optimize the available memory. Another common problem is the runtime error, CUDN status not supported. This often arises from using an unsupported version of the CUDA toolkit or QDNN. To fix this, ensure that your QDA toolkit and QDNN library versions are compatible with your framework. Compatibility is crucial for seamless operation. Optimizing model performance is crucial for efficient and cost-effective AI deployments. In this chapter, we'll explore techniques like mixed precision training to enhance speed and reduce memory usage. Mixed precision training uses both 32-bit and 16-bit floating point types to speed up model training. This technique reduces memory usage and increases throughput, especially on compatible hardware. Libraries like NVIDIA's Apex can streamline the implementation of mixed precision training. They offer easy-to-use APIs that automatically handle the conversion and scaling processes. Switching to mixed precision can lead to impressive performance gains. Some benchmarks report up to 3 to 4 times faster training speeds with reduced memory footprint. Let's look at a case study where a team optimized their model using mixed precision and saw substantial improvements in both speed and memory efficiency. Using mixed precision not only speeds up training but also allows larger models to fit in the same amount of memory, which is particularly beneficial for resource-constrained environments. As a result, teams can achieve better performance without needing to upgrade their hardware, making mixed precision a cost-effective solution. In conclusion, Optimizing performance with mixed precision and libraries like Apex can provide significant benefits in speed and efficiency, making it a valuable technique for AI practitioners. Keeping your setup up to date is crucial for optimal performance and security. In this chapter, we'll explore how to maintain your setup by regularly updating dependencies and your model. First, ensure you check for updates to your dependencies regularly. This helps prevent compatibility issues and keeps your system secure from vulnerabilities. Before updating, it's wise to create a backup of your current setup. This ensures you can restore the previous state if anything goes wrong during the update process. After backing up, proceed to update your model and dependencies. It's often helpful to consult the release notes for any breaking changes or new features. Regular updates can improve performance and introduce new features that enhance your workflow. However, ensure compatibility by testing after each update. Implementing a regular update routine, such as setting reminders or automating the process, ensures your system remains secure and efficient. To maximize efficiency and minimize setup time, start with a well-supported model from Hugging Face, like GPT-3, and ensure you have at least an NVIDIA RTX 3060 or equivalent. Focus first on proper environment setup and dependency management to prevent common errors. By following these steps, you ensure a smooth and efficient setup process that can handle future challenges with ease,